Okay, this is a walkthrough of the type of problem where a motion is described and you're told what your zero position and your positive direction and your zero time instant are, and you're asked to draw a position versus time graph of the motion. So let's say that we have an object that goes, we don't know what the object is, but let's say it goes, you have these three locations, let's call them A, B, and C. And we're told that the distance between A and B is 0.5 meters, and the distance between B and C is 2 meters. And we're told that the object starts at location B, travels to location A in 1 second, travels back to B in 2 seconds, and then travels to C in 4 more seconds. And we're going to choose our zero so our zero time is going to be when the object starts its motion. Our zero position is going to be, let's say, at the point C. And our positive direction is going to be to the right. Okay, so this is all the kind of information that problems like this will give you, and you're asked to draw a position versus time graph. So the way I would go about this, I've already drawn out the layout of the different points. That would be kind of the first step in a problem like this. The next step in the problem, to me, the best way to do this is to sketch out what the motion looks like. So the motion starts at B, travels next to A, then back to B, and then finally to C. Okay, so it follows a path like that. And notice that all of this stuff that's drawn in black is stuff that you don't have, it doesn't have any effect on any of this stuff to change your time equals 0, your position equals 0, your positive direction. Also, there's one more bit of information that isn't changed by those choices, and that's how long it takes to get from one point to another. So it says that no matter what, no matter what we choose, to get from B to A, it takes 1 second. So I'm going to write that here. That takes 1 second from this point to this point. It takes 2 seconds to get from A back to B. And then it takes 4 seconds to get from B to C. Well, the next step is, now that we have all the information in this first set of things, we have the motion drawn out and the times between the different sort of checkpoints. Now we have to use what we know about what we're told about the 0 time, 0 position, and positive direction. And that's the stuff that is not, now by making different choices of these things, are labels on the positions of these different points, and the different time instants would change. So now I'm going to choose a different color. You don't have to do this when you do these problems, but I'm just trying to sort of bring out that this is sort of a different thing now. Everything here is determined by the motion itself. Now, the person doing the physics starts to choose these other things. Okay, so 0 time is at the start of the motion. So now at each one of these points that we've drawn on the path, I'm going to draw like what the stopwatch would say when the object gets to that point. So it would be 0 seconds at that first instant. From 0 seconds, and let me just clarify, 0 seconds at that starting point, because it says specifically 0 time is when the object starts moving. We're starting the stopwatch, turning the stopwatch on at when the object is at this point B. If you start the stopwatch at the start of the motion, 1 second later, the stopwatch says 1 second. 2 seconds later, the stopwatch says 3 seconds. And 4 seconds after that, the stopwatch says 7 seconds. So now we've labeled the times on all these. And now we're going to use the 0 position and the positive direction. Okay, so position equals 0 is at C. So I'm going to label this point. This point has position 0. And the positive direction is to the right. So positive goes this way. That means that anything to the left of 0 has a negative position. Okay, so pause the video and label the positions of the points A and B. Okay, well, if this is our 0 position at C, and we're going in the negative direction 2 meters, then when we get to B, we'll be at the point negative 2 meters. And if we're at negative 2 meters, and we go an additional 0.5 meters in the negative direction, then when we get to this point A, we'll be at negative 2.5 meters. So anytime the object is at point A, its position is negative 2.5. Anytime it's at the point B, its position is negative 2. And anytime it's at the point C, its position is 0. Now that we have everything labeled, we can just start reading these values off, and I'm going to make a table of the times and the positions. Okay, so I'm going to put time in this column, position in this column. The first instant that we have information about is at the start of the motion. The time is 0 seconds. And since we're at B, we know that the position is negative 2. So we have 0 for time, and position is negative 2 meters. The next instant we know about is when the object's gotten to the point A. Time is 1 second. Position is negative 2.5 seconds. Let me say that again. When we get to A, the time is 1 second. The position is negative 2.5 meters. So 1 second for time, negative 2.5 meters for position. Then the third point that we have information about, the time is 3 seconds, and the position has returned back to -2 meters. And then the last one, well, pause the video for a second and see if you can fill out the time and position values for this last point that we have information about. Okay, so for this last point, when the object's gotten to the point C, the time is 7 seconds. The object's at C, which is always the position 0. So we can fill out 7 seconds for the time column and 0 meters for the position. And now it's just a matter of plotting these points. We have 4 points. All the positions are negative. That won't be the case generally, but in this case, what we figured out is that all our positions are negative. So our time is this way. The positions that matter to us are 0, -2 meters, and -2.5 meters. The times that matter to us are 0 seconds, 1 second, 3 seconds, and 7 seconds. Okay, so the first point is 0, -2. The second coordinate pair is 1 second, -2.5 meters. Then we have 3 seconds, -2 meters. And then finally we have 7 seconds, 0 meters. And you can just connect these. Really it wouldn't be straight lines, but you can just draw these as straight lines because we don't know anything about the way it'll curve and stuff. Later in the class, we'll talk about what the curvature of that graph would mean and stuff like that. But this is good enough for this kind of problem. So I want you to notice that 0 time does not always correspond to 0 position. That where the object is at time equals 0 just totally depends on our choices of the 0 position and what we're choosing as 0 time. And also notice that we are never going to deal with negative times, and so we will never have anything over here on the left side of the position axis of a position versus time graph. So if you ever do something and you have stuff over here on the left of the vertical axis, something went wrong. Okay, that would indicate negative times, and we just won't ever see those in this class.